Okay, for this problem, we have this following series, summation k equals 4 to 13, 3.14 to the 2k plus 1. The question is to evaluate this accurate to 6 decimal places. And as we'll see in a little bit, getting this to 6 decimal places might be a problem depending on the calculator that you have. Okay, so first off, let's just try to write this out. If I write out k equals 4, that'd be 3 times 1.4 to the 9th power, 2 times 4 plus 1. Then if k equals 5, it'll be 2 times 5 plus 11, so 3 times 1.4 to the 11. And the last term would be 3 times 1.4. If I plug in 13, it'd be 2 times 13 is 26, plus 1 makes 27. Now we recognize that this is a geometric series. And we probably could have recognized that from the original series. I've got a constant, I've got a base, and then I've got an exponent that is linear in the index k. And so that's my signal that I have a geometric series that will need to be evaluated. Now, how do I do this? Well, the formula that I gave in class goes like this. Summation k equals 0 to n of a r to the k is equal to a times r to the n plus 1 minus a divided by r minus 1. And in this expression, r is the common ratio. A is the first term. And an important note here is that n plus 1 is the number of terms. Notice that it's n plus 1 is the number of terms because this series goes from 0 to n, and so if it was from 1 to n, it would be n terms, but I have the 0 term also, so there are n plus 1 terms. So the n plus 1 over here represents the number of terms that I have. Okay, so let's see what we have here. The common ratio for my problem, the common ratio is going to be 1.4 squared. To go from this term to this term, I multiply by 1.4 squared. The next one will be 1.4 to the 13th. The first term is 3 times 1.4 to the 9th. And how many terms do I have? Well, I have 13 minus 4 plus 1 terms, so there's going to be 10 terms. So I can do that as 13 minus 4 plus 1. Another way to see this is that if this was k equals 1 to 13, then there'd be 13 terms. But I'm starting on 4, so I'm missing the 1, 2, and 3 terms. So it's not 13 terms, it's going to be 3 less than 13 because I'm not including the k equals 1, k equals 2, and k equals 3 terms. Either way, I get 10 terms. So the sum will be equal to the first term, 3 times 1.4 to the 9th, times the common ratio, which is 1.4 squared. And now I take the common ratio and raise that to the number of terms that I got. And I'm sorry, n plus 1. The number of terms is equal to 10. So the number of terms is equal to 10. Minus the first term, 3 times 1.4 to the 9th. And I divide by the common ratio, 1.4 squared, minus 1. Okay, so I'll simplify this. I get 3 times 1.4. Here I have 20 plus 9 for 29, minus 3 times 1.4 to the 9, all over 1.4 squared minus 1. And I'll mention this in passing, and this you might find this to be helpful, maybe not, but I'll mention it anyway. The number that appears here, that would be the next term if there was one. So if I were to multiply this one by 1.4 squared, I would get the thing that I circled in pencil here. So maybe that's a help to make sure that you have the right thing here. Certainly the first term is easy to get. Getting this term requires a little bit more thought. And for the formula for a finite geometric sequence, then the term that would be next is the thing that goes here. Alright, then it's just a matter of plugging into a calculator, and I did this ahead of time, and on my calculator I got 53,956, Now the question asks for 6 decimal places. Your calculator may not give 6 decimal places, and that's okay if your calculator doesn't. I'll make sure that on the test that I give you a problem that you can do on a standard 10-digit calculator. But there's the answer to 6 decimal places. So the number before the digit, and then 6 decimal places after the decimal point.